Hello, this is Hart Hagen in Louisville, Kentucky with the Climate Report. And more, I'm seeing myself as a climate corruption reporter because I believe that the climate movement is corrupt and that needs to be pointed out. One example of that is I'm going to share with you an article from The Guardian, which is the online magazine from the UK. And the idea is that climate scientists have lost all credibility with me. Climate scientists as a group, not because climate change isn't real, because it is, not because carbon dioxide isn't a problem, because carbon dioxide is a problem. Greenhouse gases are a problem. But if they're solely focused on greenhouse gases and can't think of anything else, and if they're solely focused on carbon dioxide and can't think of anything else, can't talk about anything else, then that is just messed up. It's not logical. It's not rational. It's not the kind of thing that it doesn't make scientists look objective if they're taking one small aspect of our living world and focusing only on that aspect. It would be as if, let's say I'm a heart surgeon, and I say to you that the heart is not only a very important organ, not only arguably the most important organ, but the heart is the only thing that matters. And you might say, Dr. Hagen, you might say, the heart is very important, but it's not the only thing that matters. And that would make perfect sense to you because you're a sane and rational person with a reasonable knowledge of the facts. And it's the same thing with carbon dioxide. If climate scientists are not only saying that carbon dioxide is very important, but it is the only thing that matters, then you're going to say this person is not quite right. To take one molecule and say this is all that matters and we're not going to talk about anything else, this wonderfully complex living earth that we have, and you're only going to talk about one molecule. Now, I did not say that that one molecule is unimportant, because it is. So let me just go ahead and share with you this article from The Guardian. So I'm going to be talking about this article. And in addition to this article, I'm going to be talking about an article I wrote about this article. And I'm going to be sharing with you another article that I wrote about all the different ways in which a forest is helpful and beneficial and vital. And then I'm going to go to Bluffton, Georgia with you and share a video from Will Harris's farm. And it's raining and there's runoff going into a stream. And you can compare the runoff from Will Harris's farm with the runoff from the farm next door. You have a regenerative, healthy farm, and there's clear water running into the stream from the regenerative farm. There's dirty water running into the stream from the conventional farm. And you say, all of this runoff, all of this erosion, can we talk about whether that matters to our climate, or are we only going to talk about carbon dioxide? So let's look at this article from The Guardian. It says from May 8th, and it says, we asked 380 top climate scientists what they felt about the future. And it has this banner going here, hopeless and broken is what one of them says. And another one says, I worry about the future my children are inheriting. Another one says, we live in an age of fools. Okay, you're upset. I get that. But it says they are terrified, talking about the climate scientists. It says they are terrified, but determined to keep fighting. So it's supposed to make you sympathetic to this group of scientists. And I'm sorry, I'm not sympathetic, because I've heard enough of the nonsense that wants to focus solely on carbon dioxide and not on anything else. I did not say carbon dioxide is unimportant. I said it's not the only thing that matters, and I will share with you why. Now, let me click out of this, stop the screen, and then I'm going to present the screen again, and I'm going to share with you the article that I wrote. And so in this article that says, it's entitled, "We asked 380 top climate scientists what they felt about the future. They are terrified but determined to keep fighting." Here's what they said. So Ruth Cerezo Mota is a Mexican climate scientist, and she says, "Sometimes it's almost impossible not to feel hopeless and broken," says the climate scientist Ruth Cerezo Mota. "After all the flooding, fires, and droughts of the last 3 years worldwide, all related to climate change, and after the fury of Hurricane Otis in Mexico, my country, I really thought governments were ready to listen to the science, to act in people's best interest." Okay, so she says flooding, drought, and wildfires. So let me click out of this and then share with you something. So I've been a climate reporter for 6 years. I have read a lot of the coverage, what passes for coverage in the major publications, the New York Times, the United Nations, etc., now the Guardian. And the big four impacts that are thought to be connected to climate change are flooding, drought, wildfires, and heat waves. And yes, so sometimes things have multiple causes. Let's say, I have a family history of heart disease and I want to avoid heart disease. Well, some of what causes heart disease is genetics. Some of what causes heart disease is smoking. And some of what causes heart disease is diet. It's not any one thing. So on climate change, I'm just saying that climate change is not, the problem is not any one thing, and the solution is not any one thing, but so-called climate science, they are scientists, I'll grant, yes, you are a scientist, but just because you're a scientist doesn't mean you are on the right track when you say climate change is only one thing. And what they're talking about here, so Dr. Cerezo Mota is saying, look, we have all these floods, and they're saying that is related to climate change. I'm saying, okay, yeah, it's related to climate change, but it's also related to bad land use. Flooding is related to bad land use because bad land use means you degrade the soil. Degrading the soil means there's runoff from that means there's too much runoff because degraded soil causes too much runoff. Healthy soil soaks in the rainfall, largely soaks in the rainfall. Healthy soil is going to soak in a whole lot more rainfall than bad soil, but climate scientists and climate reporters insist on blaming flooding on climate change and blaming it on nothing else. Not only climate change, but climate change is understood to mean carbon dioxide and almost nothing else. Surely it's not that simple. Surely the reality is not that simple. Because if there are multiple causes of climate change, you want to look at all the causes, at all the different causes. If there are multiple causes of flooding, you want to look at all the different causes of flooding. If there are multiple causes of drought, you want to look at the different causes. And if there are multiple solutions, you want to look at the different solutions. If there are multiple causes of heat waves, you want to look at all of the causes and not just some of them. If there are multiple causes of wildfires, then you want to look at all the causes and not just some of them. But the reason climate scientists as a group have lost all credibility with me is that they insist on blaming everything on climate change and saying that climate change has only one cause, which is carbon dioxide, and carbon dioxide has only one cause, which is the burning of fossil fuels. Surely reality is more nuanced than that. Surely reality involves multiple causes of flooding, multiple causes of drought, multiple causes of wildfires, multiple causes of heat waves. The good news is, the great thing about this is that if wildfires have multiple causes, then they have multiple solutions, and there are things that we can be doing on the way to lowering carbon dioxide emissions. I'm not saying for a minute we shouldn't try to lower our carbon dioxide emissions. I'm saying on the way to lowering carbon dioxide emissions, maybe we can look at other causes of wildfires, other causes of drought, other causes of heat waves, and other causes of flooding. And the great news is that we have solutions to flooding right here, right now, and we don't have to wait decades for the time when we supposedly, hypothetically, theoretically lower carbon dioxide emissions by switching to a different energy system, which arguably is, we can talk about that. Let me flip on through the article that I wrote. So it says, I'm going down. I talked about flooding. I talked about drought. I talked about wildfires. I've talked about the heat wave that Dr. Cerezo Mota is complaining about. She says, last summer, we had a 47°C maximum. The word, that's hot. 47 degrees Celsius. Who knows how hot that is? It seems to be. I would wager that it's well over 100 degrees, 100 degrees Fahrenheit. So Cerezo Mota lives in Mexico, and what I do in my article is that I recommend that you watch the video. Now, by the way, my article is at harthagen.substack.com. So I recommend that you watch in the article at harthagen.substack.com. I recommend that, let me get you the title of the article. The title of the article is Climate Scientists Are Stuck in the Wrong Story. So I'm wanting to say that I did an interview, you can find the link to it in the article. I did an interview with Alejandro Carrillo, a Mexican rancher who owns 30,000 acres, major landowner. And Alejandro Carrillo, the last 15 years or so, he's converted from conventional to regenerative ranching. He has cattle, sheep, pigs, horses, and goats. And donkeys. He probably doesn't have pigs. He has cattle, sheep, horses, donkeys, and I keep forgetting one of them. Cattle, sheep, goats, horses, and donkeys. That's the 5 animals that he has. And he rotates those animals in such a way as to bring back the life of the ranch so that it is, it is the grassland that it once was. It used to be, we think of these deserts that we have in in Mexico and in the American West. We think of these deserts as being places that it's just sand and it's not much vegetation. These used to be grasslands. They used to have a lot of vegetation. Some of them are regaining that vegetation thanks to ranchers like Alejandro Carrillo. And we could be doing this on a large scale. We could be doing this worldwide. And I'm here to say that if we did that, so Dr. Cerezo Mota is lamenting the high temperatures in her home country of Mexico. And I'm saying that those temperatures are caused in part by greenhouse gases, but they're also caused in part by too much sand, too much bare dirt, where you could have vegetation. If we had regenerative agriculture, then that goes hand in hand with more vegetation and higher quality soil. If you have vegetation and higher quality soil, then that has a couple of effects. One is when the sun shines on it, it doesn't get as hot. It can be tens of degrees Fahrenheit difference between sand and grass, between bare dirt and trees. So it makes a big difference in surface temperatures. One thing we don't talk about enough is that surface temperatures matter. How much do they matter? I don't know. But climate scientists should be looking into this, and they're not, because they have been trained for reasons that I cannot explain. They have been trained to focus solely on carbon dioxide. So let's get back to the article. It says that when we talked about wildfires, in relation to wildfires, I'm recommending that you look at this article, this interview that I just did with Chad Hansen, PhD, who is on he's on the board of the National Sierra Club, and he is a scholar, he is a field ecologist, and he is author of Smokescreen, which is debunking wildfire myths to save our forest and our climate. So if you want to know what really causes wildfires, talk to Chad Hansen. Chad Hansen will probably tell you that climate change, i.e., carbon dioxide and greenhouse gases, have something to do with wildfires, but they are not the only thing that causes wildfires. Can we talk about examining multiple causes so that we can implement multiple solutions? So I've talked about the big four things. That are the effects of climate change that are routinely misreported. Flooding is routinely misreported as being solely caused by greenhouse gases, when common sense tells you that flooding is a result of multiple causes, not least of all if you have bare ground, no vegetation, bad soil, then you're going to have a lot of runoff, and that causes flooding. Flooding is runoff. Flooding is excess runoff. If you don't have excess runoff, you don't have flooding. We could greatly limit and mitigate the flooding in our country and worldwide if we would increase the amount of vegetation, such as stopping deforestation, such as having more cover crops in agricultural fields, such as having more vegetation in our residential and commercial landscapes. We could be doing this, but climate scientists and climate reporters only want to talk about carbon dioxide. So, say hi to the train. Can't do anything about it when it's live. So, here's my interview with Alejandro Carrillo. Now I'm saying they're stuck in the wrong story. Okay, now this list is the bomb. I'm going to share with you a list of where I'm coming from in relation to climate change. And while I cannot prove all of this, it is based on 6 years as a climate reporter. It is based on common sense. It's based on logic. It's based on observation. It's based on having schooled myself in what makes good soil. It's based on common sense things like, if you grow an ecosystem, if the ecosystem is growing in biodiversity and biomass and organic matter, then that ecosystem in that very process is going to be absorbing more water, because living systems, if they're growing, they're absorbing water. If they're decaying and declining, then they're going to release water. They're going to release carbon. So what we should want to do is to grow our ecosystems. We should want and this includes farms, it includes landscapes, it includes forests, it includes wetlands, and it includes the ocean. Whenever we are growing ecosystems in our farms, forests, landscapes, wetlands, and oceans, whenever we're growing ecosystems, we are absorbing carbon. Whenever we're growing ecosystems, we are absorbing water, and water itself has an important positive role to play in climate change. Water can have a negative role in climate change. It depends on where the water is and whether the water is circulating through a living system. Water that is circulating through living systems is great. It's good, it's great, it's one of the best things we can possibly do to prevent climate change and to mitigate the effects, the harmful effects of climate change. One of the best things we can do is make sure our water is coursing through living systems, because water has the property of redistributing heat. More on that in a minute. But what I'm going to show you is a list of what I believe about climate change. See if this makes sense to you. Number one, carbon emissions are a problem and are a factor in climate change. I'm freely admitting that carbon emissions are a problem and are a factor in climate change. Number two, but carbon emissions are not the only cause of climate change. We have to look at living systems. We have to look at surface temperatures. That is, what is the temperature on this acre or this square meter or this square foot? What is the temperature on this surface? Is it very hot or is it a moderate temperature? And it's going to be hot if it's pavement, if it's concrete, if it's bare dirt, if it's sand, it's going to be hot. It's going to be a moderate temperature if the sun is shining on plants. That's the main thing. Plants, forests, cover crops, anything but bare dirt, concrete, pavement, or sand any sort of plant is going to be a cooler surface. So that's an example of something that is a factor in climate change other than carbon dioxide. Number three, carbon emissions may or may not be the primary cause of climate change. The climate scientists want you to think that carbon emissions are they're so overwhelmingly they're the only thing that matters. They're the only thing worth talking about. They will talk about ecosystems and such as forests as being something good in and of themselves, and they are good as far as absorbing carbon from the air. But mainstream climate scientists are not going to talk about ecosystems as a way of cooling temperatures or regulating temperatures. I'll talk more about that when I share with you my thing about if we lose a forest, what do we lose? What are all the different ways in which a forest is going to engage with the water cycle and thereby cool our temperatures, moderate our temperatures, etc. Continuing to go through my list here. Mainstream climate scientists and journalists have yet to propose a serious solution that would lower carbon emissions. So even if we were to concede for the sake of discussion, let me click out of this just a minute. Even if we were to concede for the sake of discussion that carbon dioxide is supremely important, and if I were to concede for the sake of discussion that carbon dioxide is the only thing that matters. Okay, fine. What are you going to do about it? Where's the plan for lowering carbon emissions? They don't have a plan. They act like solar and wind are going to lower carbon emissions. Not much. They act like electric vehicles are going to lower carbon emissions. Not much. You're not going to lower carbon emissions as long as you have a growing economy and endless war. Mainstream climate scientists want me to believe that they're going to lower carbon emissions while still having a growing economy and endless war. I don't buy it. I don't believe it. Okay, so growing economy, what does that have to do with it? Because I learned the following from Simon Michaud and from Tom Murphy and from Nate Hagans. It has to do with a correlation between about a half dozen things. GDP, which is the measure of an economy, gross domestic product. If as GDP rises, say 3%, energy consumption rises 3%. As GDP and energy consumption rise by 3%, so does materials throughput. All of the things that we get from the economy through mainly through mining and agriculture, hunting, fishing, forestry, those things are the materials throughput is correlated. The materials throughput is correlated with GDP. So as GDP rises 3%, energy rises 3%, materials throughput rises 3%, electricity rises 3%, complexity rises 3%, and not least of all, waste heat rises 3%. Anytime you burn something, whether it's an internal combustion engine, whether it's coal in a coal-fired power plant, whether it's all the burning that you need to do to make a solar panel, anytime you burn something, whether it's a bomb, whether it's all the things you need to burn and heat up in order to make a fighter jet or an aircraft carrier, anytime you burn something, there is waste heat. In fact, that's what characterizes humans as much as anything else, and that is we invented fire and we go all over the world burning things, and including our factories, and when we cook food, etc. We need to do something. We need to do some of that. Nothing wrong with that. But humans burn things, and so what I'm saying is, if you have a growing economy, then you have a growing amount of energy being burned. If you have a growing economy and energy, you have a growing materials throughput. If you have growing energy, economy, materials throughput, then you're going to grow the amount of waste heat. And physicist Tom Murphy told me that the amount of waste heat in like a couple hundred years, if waste heat continues to grow at this rate, then it's going to dwarf the amount of heating that is currently caused by carbon dioxide. So, and another thing, 3% a year of economic growth does not sound like a lot from one year to the next, but if you add it up, if you take between 2 and 3%, then you're going to multiply the economy by a factor of 10 in 100 years. If you grow the economy by 3%, then it's going to double every 24 years. If you grow the economy by 2%, then it's going to double every 36 years. And then it redoubles again in the next 36 years. It redoubles again in the next 36 years. So exponential growth leads to monumental amounts of growth over any significant period. And 100 or 200 years sounds like a lot of time, but Jesus lived 2,000 years ago, and 100, that's 20 times 100. So imagine taking 100, imagine multiplying the economy by a factor of 10, and then 10 again, and then 10 again, and then 10 again, and doing that 20 centuries. If you do that if you do that for 10, what's the number? 6, 8. I'm sorry for getting in the weeds on this, but it's important. If we keep growing the economy at 2.33%, then in 100 years, it's going to be 10 times as much as it is now. In 200 years, it's going to be 100 times as much as it is now. 300 years is going to be 1,000 times as much as it is now. 600 years, it's going to be 1,000,000 times as much as it is now. 900 years, it's going to be 1,000,000,000 times as much as it is now. And in 1,000 years, it's going to be 10 billion times as much as it is now. There's no way that the Earth has the capacity for that. But that's exactly what we're planning on doing, because everybody wants to assume that economic growth is a thing and that economic growth is good. Even the United Nations says economic growth is what's going to lift us out of poverty. And I'm thinking, that is problematic at best. So that's why I'm saying you're not going to lower carbon emissions when you're multiplying the economy by a factor of 10 every 100. You're not going to lower carbon emissions if there's endless war and endless economic growth. So let me I have a comment that came in, so let me address that before I go on. So Reese, thank you for your comment. It says, I think you underestimate the climate scientists' understanding of the climate forcings. That said, you're totally right. They have no idea what mechanism could get us to anything truly sustainable. So I'm not sure. Thank you for the comment. As far as what climate scientists do and do not understand, I'm just going on what I read. And, every time climate scientists are trotted out in the media, they're only talking about carbon dioxide and they're not talking about anything else. And they don't have a plan for lowering carbon dioxide. So when you say they have no idea what mechanism could get us to anything truly sustainable, yeah, I think you're right about that. So let me get back to my article and where are we here? So this is the article that I wrote yesterday. I said, item number 4, mainstream climate scientists and journalists have yet to propose a serious solution that would lower carbon emissions. I assert that solar, wind, and electric vehicles will not lower carbon emissions. And the reason I say that is because, they take a whole lot of energy. They take a whole lot of money. Remember, let's see, what's his name? I forgot his name. He wrote a book called Green Illusions. Ozzie Zenner wrote a book called Green Illusions. And Ozzie Zenner says the money doesn't lie. And here's what he means by that. When he says the money doesn't lie, it means if you want to know the ecological impact of something, look at how much it costs, because GDP perfectly correlates with materials throughput. And so if you want to know the ecological impact of an electric vehicle, look at how much it costs. Not just the out-of-pocket cost, but also how much we subsidize this stuff. Look at the true cost. Look at the financial cost of it if you want to get a good idea. So I'm going through, here's what I believe about climate change. Number 5, ecological degradation is arguably a major cause of climate change, though it is rarely discussed as such in the mainstream media or the climate science literature. So let me say something about that. My friend Anastasia Makareva is a skilled and capable climate scientist. And she says that every time we remove a hectare of natural systems, then that increases the sensitivity to carbon dioxide. So assuming for the sake of discussion that carbon dioxide does cause warming, which is true, she's saying that when you remove a hectare of forest, then the sensitivity of the climate to warming by carbon dioxide goes up. So in other words, carbon dioxide has more of a greenhouse effect when we remove natural systems. So that's why I'm saying that ecological degradation causes warming, because if you take, let's say you have a forest and then let's say you have a square mile of forest, and over here you have a square mile that's been cleared. That square mile that's been cleared causes more warming because there's less cooling taking place. In this forest that still exists, there's more cooling taking place for reasons that I'll get to when I read through one of my other articles. But the presence of an ecosystem, it has a cooling effect because every plant is a solar powered air conditioner, and the absence of plants, especially if you have bare ground, that's a solar powered hot plate. So the presence or absence of ecosystems has a great amount of effect on our climate. Item number 6, most ecological degradation is avoidable because, number 7, most ecological degradation benefits only a very few people and therefore is not a natural, unavoidable aspect of the human condition. So let's talk about ecological degradation, how it happens, and by whom. Who is causing this ecological degradation? Well, if you're in the timber industry, you're making money from cutting down trees. You're making money from ecological degradation. If you're in the mining industry, then you're mining metals and selling those metals, and you're making money from ecological degradation because mining is always ecologically degrading. If you're in the fishing industry, I'm talking about big commercial fishing, you're making money from ecological degradation, and you keep the profits, and the other species have to suffer and future generations have to suffer, but only a few people keep the profits associated with the ecological degradation that's associated with fishing, etc. Only a few people keep the profits associated with a destructive form of agriculture, such as corn farming, soybean farming, the wrong kind of livestock farming. There's a good kind of livestock farming, but the bad kind of livestock farming, only a few people keep the profits from that. You could say the same thing about construction. You could say the same thing about real estate development. Only a few people keep the profits from these destructive industries. And that's why I say that ecological degradation is something that only benefits a very few people. Let's keep reading through this. So ecological restoration is a major solution to climate change. So remember when I told you about, here's a forest over here, here's a clear cut where you've cleared the forest over here. The forest, for reasons that I'll go into in a minute, has a major positive impact on our climate, and the absence of forest has a negative impact on our climate. Item number 10, ecological restoration on a large scale will only occur if we, the people, get control of our government. We, the people, don't have control of our government. We have an illusion of democracy, but not real democracy. We have an illusion of control, but not real control. So that's what I believe about climate change. Yes, carbon dioxide counts for something. Yes, it's very important, but it's not the only thing that matters. And if climate scientists are only talking about carbon dioxide and nothing else for the most part, you have to wonder why. You have to wonder if they are dealing with reality. So let me decide here. Yeah, here we go. So here is an article that I wrote, and I'm going to be talking through that article. These are all the benefits of a forest. What if a forest has like 12 to 15 separate and distinct benefits, many of them relating to climate? And are we going to be aware of those benefits? And are we going to respect and honor a forest if that forest has so many benefits? Or are we going to allow the timber industry to come in and clear cut that forest and use it for either timber, or in other words, building materials, or use it for, burning forests for fuel? So let me make a couple of clicks here. I need to click out of this, and I need to click into this. I need to share another screen. And what we're going to do is go to this article And here you have it. If we lose a forest, what do we lose? 12 benefits of forests, just for starters. Now, this is what climate scientists are not talking about almost ever. You know, I mean, yeah, they talk about it occasionally, but it's not what you talk about once in a while that matters. It's what you talk about consistently. So if we lose a forest, what do we lose? 12 benefits of forests, just for starters. And so, evaporation. Forests cause evaporation. Evaporation is necessary for rainfall. So, you know, forests cause the evaporation, and that feeds into the next rainfall. Number two, condensation. Forests cause condensation because when they release the water for evaporation, they're also releasing um, condensation nuclei in the form of bacteria and certain organic compounds, and these nuclei make condensation possible. Next, forests are responsible for cloud formation. If you want rain, you have to have clouds. If you have, and so the condensate, the evaporation and the condensation that a forest makes happen also makes condensation, makes cloud formation happen. Next, precipitation. Forests make precipitation happen because when a raindrop falls from the sky, it doesn't always reach the ground. If it falls into a hot, dry air, it frequently doesn't reach the ground. You want a forest to be down there because if a raindrop falls into a cool, moist environment, it's more likely to reach the ground. So in this article, I go on to talk about how the forest is a sponge because it captures rainfall. The forest is a heat bank because water is very slow to warm up and very slow to cool down. That heat bank regulates the surroundings. A forest is a windbreak, and that, it's good to slow down those winds. So, because strong winds can be damaging. The forest is a filter. It's a water filter and it's an air filter. It's both. Not least of all, the forest makes oxygen, which I did not, put in here. The forest is a cooler because you have all this evaporating water, and when water evaporates, it cools off its surroundings. When water evaporates, it cools the surface, and when water evaporates, it cools the air. The forest is making a lot of water evaporate, therefore the forest has a cooling effect. The same is true of wetlands and grasslands, by the way, but we're just talking about one type of ecosystem for the sake of simplicity, which is a forest. The forest is a humidifier, which keeps the soils from drying out. And you want to keep the soils from drying out. And the forest is an air pump. The forest causes condensation. The condensation causes a vacuum. The vacuum causes the forest to pull in air. The forest creates its own moist air. Condensation, vacuum, an inward progress of air, of moist air into the forest. So I wanted to share that with you. The many different benefits of the forest. And now let's go back to let's see. Here we go. Yeah, here we go. So the climate scientists are saying so all these climate scientists were polled, and they're saying 77% of respondents believe global temperatures will reach at least 2.5 degrees Celsius above pre-industrial levels, a devastating degree of heating. And I'm thinking, okay, what are we going to do about it? What's the quickest, cleanest, safest way to lower those temperatures? Yes, carbon dioxide matters a lot, but surely we should be implementing multiple solutions. Surely we should be trying to solve these problems on multiple fronts. So let me just go ahead and show you one more thing, and that is I want to show you, I want to go to Bluffton, Georgia, and let's see what Will Harris has to show us. We're looking at two different farms. Clean water.
All right, so here we're looking. It's been a pretty good rainy day here in Bluffton, Georgia, White Oak pastures, and what we're seeing is there's a pivot of corn across the road here. On one side, it's not White Oak pastures, and then on the other side of the road, that is White Oak pastures. And what I think is important to talk about in this particular site is looking at the water coming out of the healthy system here at White Oak, but we do have some runoff, the amount of heavy rain we've had today. But that water's coming off clear. There's very little sign of erosion and soil movement and loss of topsoil, which is super important compared to acres of corn ground is eroding away and washing that topsoil off and into this stream. Along with it, chemical fertility has been added to it, and topsoil and type. So that system over there is definitely degrading today, right in front of us, whereas this system on this side is intact, resilient, holding on to as much water as it can, and what shedding off of it is clean and damn near ready to drink. So pretty.
Off of about right at 2,000 acres. That's a little over 2,000 acres of land. And it's coming off a little over 200 acres of land, and it just visually it looks like more water coming off the 200 and something off 2,000 or something. Forget the quality of the water, just the quantity of it.
Okay, now I'm going to play that same video again. This, I need to get back to, see if I can get back to there we go. So I'm going to play it on mute this time. And so what we've got here, there's clean water, and then there's dirty water. On the left, you have White Oak Pastures, a regenerative farm. On the right, you have a conventional farm, 200 acres of cornfields. Now, very dirty water on the right, clean water on the left. The clean water on the left, there's less of it running off, even though it's running off of 2,000 acres, according to Will Harris. On the right, it's running off of 200 acres, so a lot less land and a lot more erosion. Dirtier water, and whereas a lot less erosion, much cleaner water coming from the regenerative farm. So my question to you is, why aren't climate scientists talking about this? Dirty water there, because the soil is degraded, because they're destroying the soil. When you destroy the soil, you're going to, the soil that's washing downstream, that carbon is just going to go up into the atmosphere, whatever carbon was there. Plus the dirty water, if it comes from a cornfield, that cornfield has been fertilized with nitrogen fertilizer that makes nitrogen oxide, which is a powerful greenhouse gas. Why are climate scientists not talking about this? And I don't think there is an excuse for it. And that's why climate scientists as a group have lost all credibility with me. But if climate scientists will only talk about carbon dioxide and are not talking about our direct assault on the land, then they need to get a job. We need to talk about how we are directly assaulting the land and compromising our ability, compromising the ability of our land to click out of that. And here we are. So, that's a vivid illustration, comparing and contrasting what happens when we treat the land nicely and when we have a regenerative agricultural system versus when we have a destructive and degenerative agricultural system. So check that off the list. I was going to show you that. I think that's all I was going to show you. That's about enough. I think you get the point. So one of my friends, one of my readers to my blog said, Hart, I would like to share this, but you're trivializing greenhouse gases. I am not trivializing greenhouse gases. How many times have I said just in this hour that greenhouse gases are important? But if we only talk about greenhouse gases, well, we don't talk about deforestation, we don't talk about nitrogen fertilizers, we don't talk about water pollution and how that degrades ecosystems, we don't talk about the overfishing of the oceans, we're not talking about the catastrophe that is being planned for deep sea mining, which is going to be catastrophic for the oceans. And so what the mainstream climate movement is focusing solely on carbon dioxide, and they have technological solutions to carbon dioxide: solar, wind, and electric vehicles, and smart thermostats, and that kind of thing. These are technological so-called solutions to supposedly lower our carbon emissions. And I'm sorry, but as long as you're spending money on them, they are not, as long as you're spending a lot of money on them, they are not a technological solution. Plus, if you read Bright Green Lies, and if you see the profound ecological impact of the supply chains that are required to make solar, the supply chains that are required to make wind energy, the supply chains that are required to make electric vehicles. Plus, if you study the work of Simon Michaud, more than anybody, I've had him as a guest 3 times. There's nobody else in the world that I am aware of who is more, who has rolled up his sleeves and said, how much materials would we need to build out even the first generation of solar, wind, and electric vehicles? And the takeaway is that we don't have the materials to build out even the first generation of solar, wind, and electric vehicles. These things take lithium, copper, aluminum, steel. They take rare earth metals. They take cadmium. They take cobalt. And there's just not enough of these materials that are available. You won't hear that in the crowd. This article, this Guardian article, these scientists are saying, we're really encouraged that the price of solar and wind and electric vehicles is going down. Okay, but is there we could look at why the price is going down. The price is going down in part, according to the authors of Bright Green Lies, the price is going down in part because they shifted a lot of the manufacturing and the mining to China, which has no environmental standards to speak of. So they're shifting the cost onto the environment. That's part of the reason the prices are going down. But we don't have enough of a supply of the metals and the minerals that are needed to build this stuff out. So there's just fantasy and delusion is running the show. And that's why climate scientists have lost, as a group, have lost all credibility with me. The mainstream climate reporting in the New York Times and the United Nations has lost all credibility with me, and I think for good reason. So that's about. I'm here to cheer you up. So the good news is that we have an opportunity to get in touch with Nate. We have an opportunity to start living more harmoniously with nature. And isn't that the life we really want? We have an opportunity to not spend all of our time slaving away, working for a system that just wants to make endless war on people, endless war on our natural systems, endless war on our waterways. We could, survive and thrive working 20 hours a week, and then we get to spend our time doing what if our system were oriented toward the needs of people? What if our goal was to make sure that people's basic needs are met, and then we can meet people's basic needs in a way that is very ecological. What we can't do is pursue the whims and the greed of the ruling elite with the private jets and the endless war and the destructive extractive agriculture. We can't do that ecologically. So let me see. We got a couple more comments from Reese. It says, "Thanks, Hart. Interesting thoughts." Well, thank you for watching. And it says, "Soil is more planetary boundaries rather than climate science." Okay, so not sure exactly what that means, but I agree that soil is kind of a limitation. Soil is something that if we treat it right, we can eliminate flooding, drought, wildfires, and heat waves. If we treat it poorly, then we're going to have more flooding, more drought, more wildfires, and more heat waves. The soil and the vegetation that goes on top of the soil. I strongly recommend Dirt to Soil by Gabe Brown. And so that's about all I have today. Thank you so much for listening, and have a wonderful day.